Homework 4.1, Exponential Functions, Video 1. Homework due Friday, May 29th at 11:59 p.m. This is the first homework that will be included on the last test, Test 4, which will also be due at 11:59 p.m. on Friday, May 29th. We have 5 homework assignments to get through: 4.1, 4.2, 4.3, 4.4, and 5.1. So we will have hit a little bit of one other chapter. If we're going to start talking about exponential functions, I think it's a good idea to define what they look like. And then we'll figure out how to manipulate them in a calculator, how to graph them, and just other miscellaneous things about them. So what makes an exponential function exponential? Well, if you were to look in the book, the author has a specific definition, which I'll give you in a second. But personally, I think there's a better definition, because my definition is more inclusive than the author's. The author's definition of an exponential function is a function of the form f of x equals b to the x power, where b is greater than 0, but it's not equal to 1. In other words, what makes it exponential is that the x is in the exponent, and the base is just some constant. So for example, according to the author's definition, we could call something like f of x equals 2 to the x an exponential function. And it is. Or we could say something like g of x equals 1/2 to the x. But in my opinion, the author's definition is a little restrictive, because there are other exponential functions that don't fit this definition. So here, in my opinion, is a better definition. An exponential function is a function of the form f of x equals b to the g of x power, where b is greater than 0, so it's positive, and b is not equal to 1. And what this implies is that not only is the x in the exponent, but there may be other things done to it. The consistent thing between these two definitions, there are several things. Number one, the base requirements are the same. The base must be positive, and it's not allowed to equal 1. We'll see why eventually. And the other consistent thing is the location of the x's in the exponent. So that's what makes an exponential function exponential. Your variable is in the exponent, not in the base. The difference is, my definition says you can have more junk in the exponent besides just an x. So for example, according to my definition, f of x equals 3 to the 5x plus 7 is an exponential function, not according to the author's definition, but this universally across the realm of math would be called an exponential function, but not if your definition is so restrictive. Or something like g of x equals, 2/5 to the x squared plus 3x plus 2 power. As long as the as long as the variable is in the exponent only, then you have an exponential function. And there are even more variations of exponential functions that don't actually fit this form, because we can add, subtract, multiply, and divide outside of the exponent as well. For example, I could put a plus 7 at the end of this, and technically this would still be an exponential function. So although this is a better definition, I don't think it's the best definition, because there are exponential functions that don't fit this definition. But I guess if I had to come up with the best definition, an exponential function is a function whose variable is in the exponent and nowhere else. Yeah, I think that's a good definition of exponential function. So in the next video, we're going to talk about some I'm debating whether or not we want to start looking at some graphs, looking at calculator usage, or talk about some exponent rules. You know what, I think we're going to look at some exponent rules next. I've already mapped out my plan for this series of videos, but at some point we're going to need some exponent rules that we may or may not remember. So even though I may not directly incorporate them into some of these homework questions, I promise you, between now and the end of chapter 4, we will need them. So in the next video, we'll review some exponent rules, some of which you may already know, some of which you may have seen before but forgotten.